hello everyone, and welcome in another episode of the JAX for Deep Learning series. And today's session, inshallah, we will just try to continue what we started in the previous session where we talked about the different JAX ecosystem. So we will try to go in depth in those ecosystems, those libraries, and do some collabs to clarify things better. Okay, so before starting our topic, just let me introduce myself. You are with Leila Habib. I'm GDG CDB Abbas lead and WTM ambassador. Okay, fine. So before starting, just let's do a small reminder about what's an ecosystem in general and what is an ecosystem. Okay, so an ecosystem is a software development. Let's say it's a combination between various software tools, libraries, and frameworks that are designed to work together to solve a specific set of problems. Okay, so those tools here, or these tools are, let's say, those tools and technologies are intended to be used in concert, allowing developers to create a complex system more efficiently than they could with the individual tools, okay, with the traditional tools that we used to do previously. So typically, an ecosystem are used in an open source software development. Different developers and organizations contribute to the ecosystem by creating and sharing a software component that can be used by others. Okay, so this is what we mean with an open system, and all the with an open source, and all the ecosystems are basically some open source software developments. Okay, so as the number of the component grows, the ecosystem becomes more robust and powerful, enabling the developers to address and increasing solving some complex issues more easily. Okay, so that's why it's good to contribute in an open source and to, let's say, to encourage those aspects to do that. Fine, so that was about an ecosystem in general. What about JAX ecosystem? So the JAX ecosystem is a collection of various libraries and tools that are designed to provide an easy to use. Okay, so exactly like we explain what's an ecosystem. So basically, JAX does the same thing as any other open source or any other ecosystem. It just try to provide some ways or some tools or libraries that try to do, let's say, help for an easy use. Okay, in easy use, let's add the high performance platform for creating and training some machine learning models. So by using the JAX ecosystem, developers can leverage the work of others and create an advanced machine learning models more quickly and efficiently than they could with standalone tools. Okay, that's why JAX ecosystem is just something that really help the developers to go deeper in building those deep learning or those machine learning models. Fine. So in the previous session, we mentioned, we talked, or let's say we explored JAX, the different libraries, different operations that we can use with JAX, but we didn't mention anything related about building a neural network. And of course, JAX here is a very big and a huge framework. It doesn't only deep learning, but it has some other tasks, some other high performance things that it does. That's why deep learning is just a very tiny part of it. Okay, we need some other libraries, some other ecosystem to build those neural network. Of course, the majority of those libraries or those ecosystems, those parts of ecosystem are built on top of JAX. Fine. So here, those are the different or the variety of tools of building that helps to train machine learning models here using JAX. And those, let's say, the important parts of the JAX ecosystem. So we're having JAX itself. It helps us to build the neural networks, and also we can list the Haiku, which is a neural network library that helps to build some neural networks. We're having the Optax. Mainly, Optax is used for both let's say, doing some losses or describing the loss functions and the optimization for the for our neural network. So it's a library for optimizing the neural network and also to calculate the loss. And the tricky thing, or not tricky, but the best thing or the good part of the Optax is mainly to use the same optimizer that we use in TensorFlow, for example. Okay, so you don't have to learn those optimizers from scratch because it's Optax is provided by the majority of the well-known optimizers, such as the stochastic gradient descent, the Adam optimizer, and so on. And of course, we have some other libraries, such as the Flax, that is a library for the reinforcement learning. We're having the JAX NumPy, the Flax. Flax also is a well used in neural network. It's really helpful in neural network. By the way, the majority of neural networks built on top of JAX, they use Flax to do to build those neural networks here. Okay, and the main things it can do, let's say, it's easy to scale up the training to multiple GPUs or multiple machines, if we can say. And this is the main thing that JAX provide there. And yeah, there's other things. So in today's session, inshallah, we will try to get an overview about the most used ones. And let's start with the Haiku. So Haiku is a deep learning framework designed by DeepMind. Okay, so DeepMind is an organization that designed this Haiku here, but it's built on top of JAX. Okay, so Haiku is built on top of JAX. I mean, we can work together, they can work together, and they are compatible. So if we want to define this Haiku, we can say it's a numerical computing library that combines automatic differentiation, and the first class GPU and TPU support. Okay, so this is the most important thing, which is adding the GPU and TPU support. So Haiku here enables user to use a familiar object-oriented programming models while allowing the full access to JAX pure function transformations. Okay, so if we go back to the pure function, we already talked about that, but I would like to repeat it. So here in JAX, a pure function is just like a function that has no side effect. Okay, what do you mean with has no side effects? So always it returns the same output for the given or for giving same input. So this makes it easier to reason about the behavior of the function and to compose function together. Fine. So just like, let me give you an example of some pure functions. So for example, if I have a specific function that multiplied two numbers together. So the function taking parameter two numbers, let's say A and B. And here the output of multiplication, if A is 1 and B is 2, so the output of multiplication is 2 whenever we're multiplying the same numbers. Okay, so we're having the same output for the same inputs. Our input is the function parameter, and we'll be having the same output. You may be wondering about how the impure functions looks like. Sometimes we're having some random number added to our function. So let's say this function take as an input 1 and 2. It does the multiplication and add a random number. So here random number wasn't specified by the user. So for given input, let's say the input is 1 and 2, the output will be different in each time we execute the same function. Why? Because each time we execute the function, we're having a generated random function added to our multiplication of the input. That's why it's called the impure functions. Okay, and JAX here love to deal with pure functions only. Haiku provides a simple way to transform functions into a pure functions that can be used in JAX powerful transformation system. Okay, so no matter how your function is, just like by using the Haiku, it's easy for us to transform those functions to a pure function that can be used by our JAX. Okay, thanks to the Haiku. Because just like to highlight something, sometimes while building our layers there, they may have some impure things. And here we should transform them into pure functions since we'll be using the JAX. In all cases, the Haiku is built on top of the JAX. So Haiku help us to transform those functions into pure functions that can be used with our JAX here, JAX library or JAX framework. So just like to sum up, a Haiku is a simple, it's very simple. We will have a small snippet of code. It's very simple, but it's really powerful framework, especially for building neural network with JAX. So it allows us to write modular code using oriented object programming while leveraging JAX functional transformations. So the Haiku provides a built-in implementation for the common neural network components. Mainly about JAX. So if whenever you want to build a neural network using JAX, of course, so the first thing that may came to your mind is using the Haiku. Of course, Haiku is not the only one solution, but is one of the solutions. We have plenty of libraries that helps build those neural network, but mainly Haiku here helps in transforming those pure functions, those impure functions into a pure functions. Okay. So here, moving to the core tools. So Haiku provides two core tools. We have a module abstraction. Let's say the HK here, those modules, the HK refer to the Haiku, okay? Because when we are importing the Haiku, we try to import it as an HK. Okay, so here this HK just like to say the Haiku. So we're having this Haiku, Haiku dot modules and a simple function for transformations called the hk.transform or the haiku.transform. So those two functions here are Python objects that hold a reference to their own parameters, other modules, and methods that apply functions on user input. Okay? So for example, in multi-layer perspectrum, can be defined as a subclass of the Haiku module that contain layers as an attribute and implement a forward method that takes the input tensor and returns an output tensor. Okay, so in general, if you want to let's say to define this Haiku dot modules, it just like it's equivalent to layers in our TensorFlow. Okay, so people who followed with me the TensorFlow series, we was talking about some layers, especially if you are familiar with neural network. So basically you build some layers there. So the layers, the normal layers that we do now, we transform them. It's in another name. We use another name for them, which is the module. So module function is similar to layers, and we have some specific functions that helps to build those layers, such as the MLP that refer to the multi-layer perspectrum. Fine. The second function here is the Haiku.transform. So this Haiku.transform turns functions that use this object-oriented modules into pure functions. Okay, so remember when we said that Haiku here help us to transform those functions, those impure functions into pure functions. Actually, this process is done here in transform. This transform here has the module to transform those modules into a pure function that can be used with JAX.JIT, JAX.grade, JAX.PMP. Okay, so all those functions related to JAX need some pure functions. So while in the process of building a neural network, we need JAX for sure to calculate, for example, the grade, to compile, to do the just-in-time compiler, and so on. So all those functions here need JAX, even if we are doing things with the Haiku. So before calling the JAX on specific thing that is on specific module built by Haiku, we should transform it into a pure function so that we can use the other JAX functionalities on our modules here. Okay, so it does so by separating the initialization of parameter from the applications, and let's say let's say it's separating the initialization of parameters from our applications module on the input. So for example, we can transform our multi-layer perspectron into a pure function, and that's what we'll do together in the next slides. Okay, so we're having modules, let's call them layers. We're having layers. Those layers may be impure functions, may contain some impure data. So for that, because Why the layers are impure? Because generally we affect them at the initial things, we affect some random weights, and wherever we're having this randomness, that means we're not having the same output for the same input. So whenever I'm giving the same input, I won't expect the same output in all the time that I execute the same function, because there are some random generated functions. And here the transform function here help to get rid of those impure functions and to transform them into some pure functions. So here is our snippet of code. This code here tried to create an instance of multi-layer classes, multi-layer perspectron classes, from this Haiku.net modules in Haiku, and then initialize and execute the Haiku primitive using the init and the apply function. Okay, so let's try to go line by line to explain better this snippet of code and how we can use those things here. So first of all, we're creating this MLP variable, and we affect to it this Haiku.net dot multi-layer perspectron for by giving the parameters 4, 3, and 3. So here we're just creating an instance of this multi-layer perspectron class from the Haiku.net module, and this class here stands for, let's say, to build those layers here. Okay, it's just like a type of the feed forward neural network that consists of a multiple fully connected layers. We're having our argument here, 4, 3, and 3, passed to this multi-layer perspectron. And here we're specifying the number of units in each layer. Okay, so in this case here, we're having the network will have 3 layers. Okay, we're having 3 numbers. That means we're having 3 layers. The first layer, second layer, and here is our third layer. Fine. So for the first layer, we're having 4 units in the first layer. Okay, remember the neural network, it's just like exactly as we did in the TensorFlow series. So we're having some layers. In each layer, we're having some neurons. So here we're having 3 layers because we're having 3 parts. The first layer have 4 neurons, okay? And here 3 units in the second layers, or 3 neurons in the second layers, and 3 units also in the third layers. Okay, of course, you can change it as you want. This is just like an example to show you how we specify the number of layers and number of units inside the layer. And then we call the Haiku.transform. So this function is used to transform a function into a Haiku primitive, which is a special object that represents a function that has been compiled and optimized for the execution in JAX. And as you said, by using this transform, we can have 2 other additional functions, which are the init and the apply. So this transform function helped me to call 2 other extra functions, the init and apply. So here the first thing, the init, as its name refer, it just like initializing for my models here using x. X here it's a metric. It's a metric of 5. A metric of ones. Okay, so here we're having the numpy dot ones. So just like having a metric that contains 5 by 5 and contains only ones there. And then here the apply function, you just like to say go and execute those things that I'm giving you. Okay, using those initializing and on this data. Let's consider this as data that you are having. Okay, so those 2 things here, just like we're having those initializing, we could initialize and execute our feed forward neural network thanks to this transform function here. So we're sure that we're having some pure functions there. Okay, so this is about the Haiku, and so it's a very useful library that helps to build neural networks. Fine. Moving now to the second library, which is the Flax. Okay, but before moving, just let me check if you're having any question there. Any question, guys? Okay, fine. So if you don't have any question, just let's move to the Flax part. So Flax here is the high-performance neural network library for JAX that is designed for flexibility. Flax offers both low-level primitives that let you define and train any kind of models, and a high-level module that make it easy to work with a common architecture. Flax also supports advanced features like the multi-host distributed training, stateful recruitment modules, and probabilistic modeling. Okay, so it's also computing things. Let's say since it has some those computational features. So JAX provide the core functionality for defining and executing those computational graphs, but leaves out many details that are specific to deep learning application. For example, JAX does not have a built-in support for neural network layers. Okay, we did already previous we already mentioned that. Okay, we can't build a neural network using JAX only. So also we can do some optimization using JAX only. We can't load data using JAX only. Okay, we can checkpoint the metrics, the logging. Okay, all those things that are needed in building machine learning models, we can do them just like by using the JAX only. That's why we need some other libraries, and this is where Flax came in. Okay, of course, not only Flax, so we can use the Haiku also or any other library, but here Flax here is one of the several libraries that is built on top of JAX to provide some higher level abstraction for deep learning. So Flax aim to strike the balance between simplicity and some expressiveness things using or training those neural networks. So Flax does not impose any restriction on how to define your models or how you train them. You can use any kind of layer structure of an or any activation function you want. You can use any kind of optimizer or any learning rate you want it. Okay, so there is no restriction for that. You can use any kind of data loader or pre-processing pipeline you want. So Flax also gives, let's say, it's literally gives you the full control over the state of your module, or let's say over your model in general when you're training a model. Okay, so you have the whole control on this. So also it's give you the full control over the state of your model, unlike some other frameworks that hide the state behind the opaque object or the global variable. So Flax here lets you explicitly pass around and manipulate those states as a regular Python data structure, such as dictionaries, and this makes it easy to inspect, to modify, to save it, to restore it, and to distribute the state of your model. Okay, so that's why here Flax is very useful thing and you should use it. Okay, one of the main benefits of using Flax is that it's leverage the power of and performance of JAX. So we're having the same power and same performance of JAX, and at the same time we can build this model, we can specify the optimizers, loading data, and many other things. So Flax models can run on multiple devices such as GPUs and TPUs with a minimal code changes. Okay, just like changing just a very small lines of code. And Flax model, let's say, can also benefit from the JAX advanced features like the automatic differentiation, the vectorization, the parallelizations, and also the just-in-time compiler. This means that you can write a consist and, let's say, very small code while still achieving a fast executing speed. Okay, not only speed but only the memory efficiency, since Flax here is a flexible library and you have the full control as we or as we previously mentioned. Okay, so JAX here it's very flexible. You have the full control to do anything that you want. Fine. That does not enforce the convenience or the best practice. You need to be familiar with Flax and JAX at the same time. Okay, you need to know how to define the model and parameters in Flax before using Flax. Yes, we said it's easy and simple, but you should have an idea about those things. Okay, You should know or have an idea how to differ from classes attribute in Python. You need to know how to handle the stateful models like batch normalizations or the LSTM cells in Flax, and how they interact with the serializations and the initializations. Okay, so all those things they are about the Flax. Maybe you should know also how to manage variable collection to nested modules or functional transformations. So in summary, Flax here is a very high performance neural network library for JAX that is designed for flexibility since you have the full control in it. Flax offer both the low level primitives that you need or you define for any kind of models, and also it provides you with the high level modules that it makes it easy to work with the common architectures or the architectures that you already use to it. And Flax also support the advanced features. Okay, that's why Flax is a very good fit on to build some models using the JAX. Okay, so if you don't have any question, we can have a small collab to execute some of those to make Flax in practice. Okay, so before using Flax, the first thing that we should do is to install it. Okay, here I'm using the Google Colab. So the first thing that you should do is to install Flax. Okay. Okay, close this one. Terminate other sessions. Okay. Here it's not connected. Okay, so here we are installing this Flax here. We need to install it before using it. Okay, so here my installation just done. And now let's import the needed libraries. So to build a neural network, we try to build a very simple, handy neural network. So let's import the needed libraries. For example, we need JAX. Okay, we will need the JAX, or let's say we need only a random from JAX. So let's say from JAX import random. Fine. And we also need NumPy, or let's say the JAX NumPy. So import JAX.NumPy as GNP. Fine. And last and not the least, we should import the Flax. But we won't use directly Flax. There is a linen function that helped me to build those neural network. Okay, because there are plenty of libraries that we can import from Flax. So we just simply we will try to linen here as an N. Fine. So let's execute those things. So this is just like a call to build our neural network. Fine. So I'm having my libraries in hand. Let's build our class. So we're having a class. Let's call it multi-layer spectrum. Okay, I'm having a capital C here instead of having multi-layer spectrum. And here we give it this NN or neural network that we're having, and we call from it the module. Fine. Here in my class, I should use an annotation or decoration called the NN dot compact. I just need some, I think it's written like that, yes. So this at neural network compact is a decorator is used to define the forward path of the neural network, okay, in more consistent way. It allows you to define the neural network architecture in a single function rather than having to define the forward pass and the neural network architecture separately. Okay, so just like it's a part of the Flax library, which is built on top of JAX, of course, and it's used to define the neural network modules in a more consistent way, which can make it easier to write and debug your code. Okay, so let's try to use this. Fine. Let's define our function. Let's call it. This is a call function. Giving it. Okay, fine. So here we will be just like using as an argument. We'll be using the x here as an argument. Let's just like get rid of these things here, and we try to return x. Fine. So what is this x that we'll be needing here in my define my this functions? So x here refer to this NN of Flax that we call it previously, and from here we can call our dance layers. Okay, so basically we will try to do to define fully connected layers, let's say with 64 output units, and apply on them some activation functions such as the ReLU activation functions. Of course, you can add as many layers as you want. Okay, of this X, having it here. Fine. And also, let's add some ReLU. Okay, let's call the ReLU for X. Okay, like just like exactly like what we did previously in the in the TensorFlow, but this time with Flax. Okay, so here we can recall the same functions. You can just like simply recall. So we will be having two layers that contain those two depth layers with 64 units, and that applies the ReLU activation functions. And as the output, let's say finally for the output, the last layer, we should define a fully connected layers with a specific number of outputs. Okay, let's say the 10 outputs, or yes, 10 outputs. For example, if we're using the Amnes data set, so here we should have 10 outputs. Okay, so here my dance, and I should specify for the output 10 outputs. Okay, so like that, I just like built our model, or I designed the model using Flax. Okay, just like pretty simple, just calling some fully connected layer. We're having the dance layers here. This is the activation function used for it, and this is a second layer for it, and this refer to the output layer. And of course, we're adding those lines here to the X, so by the end, we should return X, and like that, we will have let's say our neural network that contain 4 or 10 output layers in the end. Okay, now I should call a key variable from random key there to generate it. So this key will be used to initialize the random number generator, which is used to generate some random numbers for our neural network. Okay, so let's call it a key. And this key, we call the random because we already imported random previously. And here we have just like claw with, yes, the random key from here, and give it this. Okay, sorry. What's the problem here? Okay, let's give it some 0 here. And then we recall our X. Remember, X is our layer there. So X here, we just like give it this random dot normal. And in normal here, we give it our key. And then we should generate a random array, let's say of any specific shape, let's say 10 by 700 or any specific number, using this random normal function. Okay, so this random normal function, it's a function from JAX library, and the array is used as an input to my neural network. Okay, so of course we need data, we need inputs to my neural network. So let's say the input is just like any array, any specific array that we can call. Okay, so we're just like trying to prepare arrays, or let's say here we're just like preparing the input to my neural network. Fine. Now let's call the multi-layer perspectron, because we said that we are having a specific function called the MLP. This MLP helped me to create an instance of the multi-layer perspectron class, which is defined as well in the code. Okay, so let's with our variables here and call the MLP function. Let's execute it. And then by calling the MLP, it's give me the hand to call the init function and the apply function. Okay, so let's say this multi-layer perspectron just create an instance for this MLP, but we should initialize it. Okay, initialize the parameters of the neural network, and then the method take the parameters that we initialize, and then the input array as an argument, and return the output of a neural network. Okay, how we can do that? Just like by using this net function here, where when we instantiate the multi-layer perspectron. Okay, so first of all, we said we should initialize the parameters. So let's call it param to refer to the parameters. And here we're having net.init. And in this net.init, we should give it the key, my key. Okay, this random number that we got here, and my array. Array here might represent my inputs. Sure. So here we already initialized things. The second thing that we should do is to execute things. How we can execute things? By using the second function, which is apply. Okay, so here to get the output. Okay, because we will get the final output of my neural network. So let's call it y here. Okay, and then using this my class, always with this net class, and we call the apply function. So in apply function, we give it my parameters here. Okay, I'm just like giving it my param. And the second thing, we should give it x. X is always my array there. And yeah, so like that, we just like created a neural network. We design it, and here we initialize it with my data here, and from here I get my output. So this is my output. Of course, you can use data, because here we're just like trying to do some quick way how we can implement the Flax. Of course, you can load your data and use it on your data set. Also, you can use it on the fashion amnes data set and so on. Those here, I'm just like showing you the correct step that we should follow to build a neural network using this Flax library. Okay, checking if there are any questions out there. Any question, guys? So here we can just like so this is the code in case you just like want to copy it, or just like keep it here in the screen for a couple. Okay, so here is the code in case you want to copy it. Otherwise, we should follow our session. Okay, moving now to the Optax. Fine. So far we discussed the how we call it. We discussed the Haiku and the Flax. We wrote a specific code using the Flax. Now let's move to the Optax. So Optax is a library that provides building blocks for gradient processing and optimizations in JAX. Okay, so the gradient processing refers to any transformation or manipulation or gradients, such as clipping, scaling, masking, adding noise, etc. Okay, so optimization refers to any algorithm that updates parameters based on the gradient, such as the stochastic gradient descent, the ADAM, and I don't know, all the optimizers that we use to use in TensorFlow. So they are provided here. So Optax aim to facilitate research by allowing researchers to easily combine low-level ingredients into custom optimizers or other gradient processing component. For example, one can create an optimizer that combine Adam with a gradient clamping and weight decay using a few lines of code. And Optax is a gradient processing and optimization library for Flax. So it's designed to facilitate research by providing building blocks that can recombine in a custom way in order to optimize parametric models such as, let's say, any optimizer that you want to use, let's say the Adam optimizer, but not limited to deep learning network. So Optax is designed to work seamlessly with JAX and provide a set of utilities for common optimizations task. I mean, okay. So this is an overview about the Optax. If you want to talk more about the Optax, so we mentioned that Optax here, as its name refers, it's used for optimization. So this OPT here in the beginning of everything here, it just like refer to the optimization. So Optax provide a number of let's say a number of standard loss functions. Okay, we have some number of loss functions in deep learning, such as the L2 loss, the softmax cross entropy, the cosine distance, and so on. So these loss functions here, these losses accept batches as an input. However, they perform no reduction across the batch dimensions. So Optax losses here are also pure function that takes predictions and targets and return a scale value. Okay, and same thing for the optimizations. So Optax provide a number of standard optimizations primitives such as the stochastic gradient descent or the Adam optimizer. These primitives can be combined using the Optax chain. Okay, we have a specific function that we will use it in our next collab. So the Optax.chain here, it's a function to create more complex optimizations algorithm. Okay, so we're having the Adam. Yes, Adam is good. It's really doing the good things. But here, Optax help me to have a more complex optimizer, maybe to get some better results, and we will see that in our next collab. So Optax contain implementation of many popular optimizations and also loss functions. So all the loss functions that you know, all the loss functions that you worked previously, you can call them here using this library Optax. Okay, so here just let's have some practice. It's a Flax in practice, but I just like want to add some lines to add the Optax things. Okay, of course, to use Optax, you should install it, and the import you should import also the Optax. Fine. So here I'm having my variables, and let's say just like want to use this chain function. Okay, we said that chain, it just like help me to combine many optimizers to get some great results. So if you can see, just like by creating here Optax and clicking the dot here, we're having all the existing optimizers. Okay, we have the ADA grade here, the ADA factor, the ADAM. Okay, so all the optimizers that we know, we can call them here, of course, plus some new functions, some added functions. Here, just like we want to try to create a new complex optimizer. To do that, I should call the chain. Okay, so here it's C. I'm trying to call the chain function. So let's say the Optax scale. Yes, I mean Optax dot scale by Adam. Okay, scale by Adam. So here is my function. So what is this Optax scale by Adam? Okay, so as we said, Optax is a library for gradient-based optimizations in JAX, and it provides a set of composable optimizer. So here we're trying to build those complex optimizer. So to build the complex optimizer, we should use this Optax.chain function to chain together two or let's say two optimizers primitives using I will just like try to use the scale by Adam and another Optax scale. So scale by Adam here scale the step size of an optimizer by running the average of a second moment of the gradients. Okay, and this can help to improve the convergence of my model. Fine. The other thing that I should call is the Optax dot scale. Okay, and here we may give it some specific random rate, learning rate. I mean random rate. Okay, I mean some specific learning rate. Okay, so what is this Optax scale? It just like it helped me to, let's say, to scale the step size of the optimizer by fixed scalar, any scalar value, which can help to control the learning rate. Okay, so here I'm just like having a new complex Optax chain or Optax optimizer. Fine, so let's call the optimizer here optimizer. I just like forget my optimizer here. In any cases, it's just like a variable, and let's call the Optax dot. Here we should call any optimizer that you want, for example the stochastic gradient descent. Okay, and of course we specify the learning rate. We should specify the learning rate. So here my learning rate should be any learning rate that you want, because here just like a handy example. And then calling my optimizer one more time, but this time I try to chain it. Okay, Optax dot chain. Right. So here I will do something complex about the more than the complexity that I'm having here. So this takes here is just like a complex chain, and we add to it this stochastic gradient descent. We add this optimizer here. Okay, so this is a very powerful thing that Optax helped me or allow me to do. So here, Optax stochastic gradient descent, just like I want to highlight this specific part, always, we must specify the learning rate when we are using those popular gradient descents. Okay, so whenever you're using the Adam optimizer, the stochastic gradient descent optimizer, okay, we should precise the learning rate. There is no default learning rate. You have to precise it here. Okay, and finally we should let's say we should initialize the we should call the init function to initialize the optimizer state, which can be used to update parameters of the neural network during the training, because here the role of the optimizers is to update the to update my things, to update my neural network or the parameters of my neural network. Remember, when we talk about the weights, we said that first of all the weights are generated randomly, but after calculating the loss functions and thanks to the optimizers, those weights are adjusted. So here the optimizer helped me to update the parameters, but to do that we should call the init functions. Okay, we should initialize it. This is the tricky part here by using JAX. Each function that we're trying to do, we should initialize it. So calling my optimizer, okay, calling my optimizer here, and call init the init function. Okay, so here is my init functions, and simply I give it my previous parameters here. Okay, so here we are using this optimizer on my parameters. And like that, my the optimizer or my values in my optimizer are updated in each time that we are doing the training, because we still didn't do train here. So the parameters will be updating using this complex, let's call it a complex, yes, this complex optimizer. Okay, it's not simply stochastic gradient descent, but it's more complex here by using the scale by Adam and the stochastic gradient descent all together here in one simple optimizer. So we for sure will get some extra powerful things or some extra powerful output or result. Okay, so here just let me check if you have any question. Okay, fine. We're having Muhammad here saying, can we use GPU and TPU here with Optax? Of course, this is the benefit things about JAX in general, because both Optax, Flax, the Haiku, all of them, they are built on top of JAX. Okay, so here the main things is JAX, and JAX is built to accelerate things. And when we talk about the accelerating, for sure the GPUs, all the multi devices, multiple machines can came here. And when we say that we should have some, we can have some multiple GPUs, some multiple TPUs. Okay, so here this is the good part about JAX in general, because we can execute it on the TPU with either small changes, or when we talk about the JAX with no changes. Okay, because previously we should to change some in our code to do things. By the way, here my code is just like it's executed on the GPU. Okay, so everything that I did here is executing using the GPU. You can do the same thing using the TPU. Okay, so this is the good part of JAX, and this is why we use JAX in general. By the way, sometimes we call JAX the NumPy on GPU. Okay, because it's kind of tricky to use NumPy with GPUs, but here JAX is much accelerated and we can use it easily with the GPUs. Okay, do you have any other question, guys? By the way, the this JAX is a very trendy things nowadays. So everyone is talking about the JAX, the Haiku, how to build, and it's mainly used for research. Okay, you find researchers, they are using more JAX to do their research in the daily things there. Okay. So we still have some couple of minutes. So if you have any question, don't hesitate to ask. Okay, we're having Muhammad is saying, is it easy to do? Okay, so here everything will be easy by practice. I don't know if you are deep learning developer or not, but if you notice, then when you started, everything was like just like everything was seemed to be hard, especially to build those models. And then once you get hand on those models, hands on projects, so everything you will have an idea how to do things and how to do that and this. Okay, so before digging into JAX, you should have an idea how to build the models. Okay, how to build simple models, let's say models from scratch using Python, models using TensorFlow and so on. And then try to learn JAX, because JAX is very something essential before doing Flax and before calling those Optax and the other. There's not only Optax, there's also another function that called checks that have to test my functions, to test my models. So before using all those libraries or all the other ecosystems, here it's mandatory to get hand on those things there. Okay, so you should learn about JAX first and then move to the other libraries. Okay. Okay, so we're having another question saying that, can we transfer a TensorFlow existing model to JAX? Of course, yes, you can add JAX to your existing TensorFlow models. You can combine both of them all together. Okay, so you can, for example, let's say you're having an existing PyTorch or TensorFlow model and you want to add to it another model that uses JAX. So for sure you can do that. Okay, so they are kind of compatible and they can work together, especially if you the good things about JAX is just like it's more accelerated. Okay, it's accelerated because it's used the just-in-time compiler. Okay, and also you can use the XLA. Of course, XLA you can use it with TensorFlow also, so your code will be much accelerated there. Thank you so much, Mohammed, for your questions. Thanks a lot. Thank you, Mr. Atiyah, for attending today's session too. Really glad to see you here again. Okay, fine. So if you don't have any other question, we can stop here. You can find some repositories, or let's say only one repository in my GitHub talking about JAX. Okay, so when I was learning JAX, I did a couple of exercises or a couple of examples, and I pushed them in my GitHub repository. So you can check Leila 828 on GitHub, and you can find plenty of projects. One of those projects or one of those courses, the JAX for deep learning there. Okay, just like to have some much extra examples, because of course 1 hour here is not enough to do those things. Okay, fine. So by that, we arrived to the end of our session. Thank you so much for attending, and see you in another episode, inshallah, about JAX. And I guess that it will be much advanced, maybe to build some models using JAX and all the JAX ecosystem there. Thank you so much, and salam. By the way, Ramadan Kareem for all of you. See you in Ramadan, inshallah.